to continue doing some of these differential equations examples. There's going to be several in this video, so if you need to stop and pause or whatever, you feel free. Do whatever you need to do. So we're going to start with this one. Let's see. So we're going to start the same way we have in the last couple. We're trying to get x's on one side, y's on the other. So we're going to multiply both sides by dx. Oh, okay. So those cancel. So I have dy equals e to the x over y dx. And then I need to get this y on the same side as the dy. So now I'm going to multiply both sides by y to make those cancel. So now I have y dy equals e to the x dx. And now I'm going to do the integral of both sides. So this will turn into y squared over 2 equals, lucky for us, e to the x is its own derivative and antiderivative. So this is just e to the x plus c. And then since we're solving for y, multiply by 2. So we got y squared equals 2 e to the x plus 2c. And then the square root. So y equals plus or minus square root of 2 e to the x plus 2c. There you go. So it looked gross to start with, but e is kind of nice that it's its own derivative and antiderivative. So it wasn't too bad. So there we go. There's that one. This is the next one we're going to do. And when you look at it, you're like, hold on, that's not two things multiplied. So before we start, both of these terms have a y in them. So before we start, I'm going to recopy dy dx. And then equals, I'm going to factor a y out of everything. So this is y times 4x cubed minus 6x squared. And now you have something that you can separate. So I'm going to multiply both sides by dx like I was doing previously. So we got dy equals y times 4x cubed minus 6 squared dx, and then I'm going to divide by y. It's multiplied, we want it on the other side, so we divide. So we have dy over y equals, let's see, 4x cubed minus 6x squared dx. And I'm going to rewrite this left side as 1 over y dy. And now we can do the integral of both sides. And in case you forgot, when it's 1 over something, the integral, the antiderivative, that's when you get a natural log. So this side is natural log of y, and then equals, this side is just your power rule. So if I add 1 to the exponent here, it'll be 4, and divide by it. So this will just be x to the 4th. And then minus, if I add 1 to the exponent here and divide by it, that would be 6 divided by 3, which is 2. So this is 2x cubed. And then don't forget your plus c when you're done. And then this is close, but it's at not, y. To get rid of the natural log, you make it a exponent of e. So we would do e to the natural log of y equals e to all of this jazz, x to the 4th minus 2x cubed plus c. And the reason we do that is because the e and the natural log cancel. So we have y equals, and then that's your answer, e x to the 4th minus 2x cubed plus c. We solve for y. Hooray. Here's our next one. And again, it's kind of like the previous one. We don't currently have two things that are multiplied that we can separate, but both of these terms have an e to the negative y. So I'm going to factor that out before we start. And now I can start separating things. So I'm going to multiply both sides by dx. So I got dy equals, and I'm going to rewrite this as 1, just kidding, as x plus 10 dx over e to the y, right? A negative exponent sends it to the bottom of a fraction. And the reason I did that is now I can see this is actually divided. So to get it to the other side, I need to multiply. So I multiply both sides by e to the y. So now I have e to the y dy equals x plus 10 dx. And so we're going to integral both sides. Lucky for us, e is its own derivative and antiderivative. So this side is just e to the y. And then equals x squared over 2 plus antiderivative of 10 would be 10x plus c. And then the way you get rid of the e is by doing a natural log. So we do natural log e to the y equals natural log of all that stuff, x squared over 2 plus 10x plus c. Because the natural log and the e cancel, so we got y equals natural log x squared over 2 plus 10x plus c. And since you've solved for y, you're done. Hooray! And that's where we're going to stop.